right, let's continue with that 7.1 section. All right, this chunk, this part of the guided notes deals with percent increase or percent decrease problems. All right, so what you're going to do is you're going to calculate the amount of the increase or decrease, and you're going to be dividing that by the original amount. That's probably the most common mistake, is dividing by the wrong thing. So here I have a situation where a coat was reduced from $250 to $200. So to get the amount of the decrease, you take its new cost, subtract the original cost, and you're going to divide it by the original amount, which is the 250. Now, if you do approach these problems by correctly setting up that it's the new price minus the original, then when you get a negative, it's actually telling you that the price of the coat went down. And now we're going to calculate 50 divided by that 250, which turns out to be 0.2, negative 0.2, which would equal a negative 20%. If we move that decimal 2 places over, it would be 20%, and then the negative just means it was 20% off, right? That it was a percent decrease. So we could interpret that then to mean, so the coat was 20% off, okay? Now let's take a look at this next one. So on this one we have the salary for a school district. Average salary was $54,884, and then 3 years later the new average salary was $68,000. So notice it went up there. So we could find the percent change by taking the new salary's average, the new average salary, and subtracting the original. And then what I'm going to do is I'm going to divide by the original salary. That's probably the biggest mistake, is not dividing by the original salary. You're trying to say whether it went, what percent up or what percent down it was from the original, okay? So 68,000 minus the 54,884, okay, that 13,116 I'm getting. Okay, that is positive because the salary increased. That's why that's positive. Now I'm going to divide that by the 54,884, because that's what I'm comparing back to. And what I'm getting is that this would be about 0.23, and I'm going to go ahead and write down what I see on my calculator. 238976751. Okay. Now I wanted to talk about what it means to round to the nearest tenth of a percent. You don't round to the nearest tenth at this stage. You wait until you've changed it into a percent. So see how that would be 23 and then 0.8976751. Now I'm going to take and round to one place after the decimal. And because this is a 9, I would say this is a 23.9% increase. Okay, and that's a 23.9% increase over those 3 years total. You know, like yeah, it's not per year. It's 23.9% for the 3 years. Okay. All right, on question number 9, what I'm trying to get at here is that you got to pay attention to your reference value. So like on both 7 and 8, when we talk about it being a 23.9% increase, that's a 23.9 increase on Let me get rid of that mark. That's a 23.9 percent increase over what it was originally. So that's the new salary was a 23.9% increase over this original salary. So if I did 23.9% of that and then added it back to the 54,884, that would give me the $68,000. Okay? And the same with this one. When I talk about something having a percent decrease, okay, it's not moving. Let me get it here. Of 20%, a 20% decrease or 20% off, that means if I did 20% of the original amount and then subtracted it, I would be at 200. Okay? So it really matters what your reference value is that you use. So if I've got that a Honda is 40,000 and a Toyota is 50. So let me get that information down here or over here. So okay. So a Honda was 40,000. A Toyota is 50,000. So we could say the Honda is 10,000 less than the Toyota. Or we could have said the Toyota is $10,000 more than the Honda. Now, that $10,000 difference is the absolute difference in those two prices. If I wanted to report things as a percent difference, if I wanted to say the Honda cost so many percent less than the Toyota, I'm going to put an A and a B on these. If I was trying to do that one, then what I would want to say, what I would want to calculate, is I would want to take that 10,000 change, but I would want to be comparing it to, if I'm saying it's that percent less than the Toyota, then I want to compare it to the Toyota. Okay? And the Toyota was 50,000. So if I did that, that would wind up being 0.2. That would wind up being 20%. So it's 20% less than the Toyota. Okay? Now, for part B, I want to talk about the Toyota costing this percentage more than the Honda. So the Honda is my reference value. So that $10,000 more that the Toyota cost, I want to compare that back to the cost of the Honda. And if I did that, that would be 0.25, which is really 25%. So the Toyota cost 25% more than the Honda. So that means if I took the Honda's price and I found 25% of it, I'd get 10,000, and I'd want to add that to the Honda price to get my Toyota. Where part A says that the Honda cost 20% less than the Toyota, then that means if I did 20% of the Toyota's price, I'd still get 10,000, and then I would subtract that from the 50,000 to come up with Honda's price. So there's some things about percentages. Percentages are less intuitive than people think, and a lot of times people make mistakes. They make assumptions about percentages that are not true, and they're not careful about what the percent reference value is. Whether you should be using the 40,000 or the 50,000 down here makes a difference. And it comes from that right there, okay? less than the Toyota, more than the Honda. The then part is what determines what your denominator is going to be. All right, number 10 is another tricky situation. Here, instead of saying, what they're saying is that the current price of this meal at this fancy restaurant is 200% more than the $100 that it used to be. 200% more than. It's not saying it's 200% of the $100. So that's the point of this problem, is careful reading. If it's more than versus of. Okay? So let's think about this. So it used to cost $100. Okay. The current price of the meal is 200% more than that. So I'm going to calculate 200% of $100. And 200% is the same as 2. Because I still divide by 100, I would just get 2. And then of is multiplication, and 2 times 100 is 200. Now that 200 that I get is not the final answer. That's not the current price of the meal. Current price of the meal is the $100 it originally was. It's 200% more, which in this case would be $200 more. So the current price of the meal would really be $300. That would be the answer. So the meal's really tripled. If it increased 200%, it really turns out to be 300% what it was originally. So you've got to be on your toes with percents. You've got to watch that. More than versus of. All right, now the point I'm trying to make on question 11 is this idea, is this very situation. This happens a lot. So if I have a situation, maybe I bought a stock that's worth $100 when I bought it, 100 per share. All right, the price of the stock dropped 30%. A week later, it increased by 30%. If I sell it at that moment, will I break even? In other words, did the price of the stock get back up to $100? So let's work through that. So it was $100. Okay. All right, then it said it dropped by 30%. So I'm going to take 30% of the original price of the stock. That would be 0.30 times 100. That would be $30. That's not what the stock is worth. That's how much it dropped. All right, so if it dropped that much, then my stock, let me see if I can get that to stop. Okay. All right, then my stock is actually now worth $70 at that moment in time. All right, but a week later, it says it increased by 30%. All right, so if it was $70 and it increased by 30%, let me calculate 30% of 70 to get the amount of the increase. That would be 21. But you see how that means that my stock is now worth, at that moment, it would be back up, but it would only be back up to $91. All right, the issue is, originally I was doing 30% of this reference value of 100. But once that 30% decrease happened, when I turned around and tried to do 30% increase, it was 30% of only 70. So the amount of the increase was not enough to get it back up to the $100 per share. I would not break even. Okay. All right, and then just a couple more things. Sometimes people misuse statistics or math in general on purpose. Okay, they realize sometimes we don't feel like checking whether what they say is accurate or not. Sometimes it's not intentional, sometimes it is. Here the government was promising voters there was going to be a 15% cut in spending for the next fiscal year. All right, the budget for this past year was $72.5 million. It's projected to be $64.3 million for this coming year. And so we're trying to find out if that's really a 15% cut in spending. So what I could do is take 15% of the 72.5 million, and I'm not going to write all the zeros. I'll just remember when I do it that it's in millions. Okay, and if I do 0.15 times 72, oh, wait a minute, I didn't do it right. 0.15 times 72.5, what I get is 10.875 million. Now that 10.875 million would be the 15%. So if that were supposed to be the 15% cut, then I could check to see whether they did that or not by taking the 72.5 and subtracting that 10.875 that represented a 15% cut. And when I do that, if it truly were a 15% cut, then the new budget should have been that many million. And even with rounding, you know, that would only be like 61.6 million for this coming year. So it's not going to be a 15% cut. Right now, your alternative to how I just did it, let's see if I can move this over, would have been to find the amount of the decrease. So to take the 64.3 minus the 72.5, divided it by the original amount, and actually calculate what the percentage off would have been. Is it really only that? That doesn't seem right. And it turns out to be, when you're finished with that, a negative 0.1131. If I change it to a percent and round, it'd be about an 11.3% cut, really. So you could have explained that either way. You could say, no, they're not keeping their promise. And you could say, because if they were, the new budget should have been 61.625 million. Or you could have said, nope, they're not keeping their promise because that really was an 11.3% cut, not a 15%. Okay. All right, another misuse of percentages I see a lot is this. Stores advertising a sale of 150% off. Okay, so we know how to do like 20% off. We take the amount off, the percentage off, I mean, and we find that percent of the item. Okay, and 150% would be 1.50. And if you did that, then that would mean, that would be 750. That would mean you're supposed to take $750 away from the cost of the item, but the item was only $500. You cannot take away more than you even have. That wouldn't make sense in that context. So would the cost of the item now be a negative $250? And if so, what would that even mean, right? What is that? That they would pay you $250 to buy that item now? So that's just not really possible. Yet, when I'm listening to the news, reading articles or listening to the news on the radio or watching the news on TV, people will sometimes say that something is 350% lower in price than it used to be. Okay? It can't be more than 100% off. A percent decrease can't really be more than 100%. Percent increase can, but percent decrease cannot. Okay, so this doesn't make sense here, does it? Not possible to have more than 100% off of something. All right, now this one is similar to what we were doing earlier. Here, a store advertised that merchandise was reduced 25% and that an additional 10% discount card would be given to the first 200 people who entered the store. The advertisement then stated this amounted to a 35% reduction in price of an item. Is the advertiser being honest? Okay. So it kind of depends. It depends on how the store is going to calculate the cost of the item. All right. So to make it easy, let's go ahead and imagine we're buying something that's $100. If we applied the 25% off first, if it was a reduced 25%, okay, and it sounds like the merchandise was already reduced 25%. So it sounds like that's going to be applied first. So if I did 25% of the 100, that would be 0.25 times the 100. That would equal $25. So that original $100 item would now cost me $75. Okay. Then they're telling me, they've given me a discount card for 10% more, 10% off of that. So if I do 10% of that 75, which would be 0.10 times the 75, okay, that would wind up being 7.5, $7.50. So that means, in addition, I could subtract 750 from that, and the 75 minus the 750 would mean the item would cost me $67.50. Now, they were claiming that this was a 35% reduction in the price. But that $67.50, the new price, minus the original $100 price, divided by the 100, would tell me what the actual percentage off was. So if I do that, I would get that it was a negative 32.5%. So it would have been only 32.5% reduction. Because the way it was worded, it's like they had already reduced the merchandise 25%, and now I'm getting an extra 10% after that has happened. So that means that 10% isn't being applied to the $100 original cost of the item. It's being applied to that reduced price of $75. So it doesn't really turn out to be a 35% reduction. It's only a 32.5%. All right. So I guess the point is that percentages are a little trickier, I think, than people sometimes think. So you have to really be careful when you're working with them and making sure that you're interpreting them correctly.